Okay, today is 3/15. It's the Ides of March. Beware Caesar. You don't get that reference. That's okay. So to calculate a diversity index, we're going to count individuals for all these species. And there's one species here that's really easy to count because the little purple flowers, the little violets, there are none. So we got to count the yellow flowers. They're roughly dandelions. Go ahead and everybody count. If you want to you can screenshot from YouTube, or you can take a picture of this and count, come up with a number. Okay, so I think it's a safe bet. It's probably 45. So we're going to say there are 45 of those little yellow ones. Now, mind you, this is not an entire biological community. We're sampling here. So we took this, square or rope or whatever, and we cordoned off an area, and we're just counting the number of species in that sample. Should it be representative of the whole community? Hopefully, if we did a random sample. How many of species 2 do we have? This one's easy. 4. That's the little red flowers. And what about the little blue flowers? 3. Those are actually modeled on a bluette, which is a native wildflower that should be popping up in the next few weeks. If you look at the tree border here between the high school and the golf course, you'll find little bluettes growing in the grass. They're sweet. Okay, so we've got our small n numbers. That's the number of each individual species. What we want to do is take each of those and multiply it by 1 less than itself. So d sub s is going to equal 45 times 44 plus 4, whoops, I did that wrong, plus 4 times 3 plus, well, the 0 goes away, so we can get rid of that, plus 3 times 2. And if you aren't sure where those numbers are coming from, here's your 45. That's 45 minus 1. Here's your 4. Here's your 4 minus 1. And here's your 3, and there's your 3 minus 1. So you're taking 1 less than the number of species. Now we need to divide that by the total number of individuals. How do we get that? We literally add up all of these. So 45 plus 4, 49, plus 3, what do we get? 52. And notice that that denominator is 52 times n minus 1. We're going to. Okay, so let's get the numbers. So I get 0.753 for my diversity index. Now we said 1 is 0 diversity, Gesundheit. The lower the number, the more diverse the ecosystem. This isn't all that diverse, is it? It's a fairly large number. If we compare to this, so this one had no diversity, this had a diversity score of 1. It's more diverse than that, for sure. What about if we compare it to this? Now, this doesn't have very abundant life. There's not a lot of individuals there, but it's fairly diverse. All the individuals are fairly even. You have pretty good species evenness. What about that one? Way more abundant. About as diverse. Now, it's a little lower in diversity because one species is starting to crowd out the others. So again, why does this have such a low diversity score? It's being dominated by one species. Those dandelions are dominating the entire biological community. So with that in mind, so this, obviously, this is a lab that I stole and modified. It was she shells, but beans are easier for us. So you're actually going to sample some biological communities, and your biological communities are here in these bags. And we've got bags A through F, and in them you're going to find some beans. Now there are 5 possible species of beans, and hopefully you can tell them apart, but we're going to give you a handy-dandy interpretive map to them just in case you can't. These little black ones here are the black beans. Pretty easy to pick out. We have Great Northern beans, which are small and white and smooth. We have pinto beans, which are what you make refried beans with. We have black-eyed peas, which, believe it or not, are in fact a species of bean. I'm not in charge of common names. And we've got the big boys. We've got some dried lima beans. So to sample your biological community, you're literally just going to reach in, take a handful, and put them on the desk. And then you're going to sort them into little piles and count them. If you flip to the second page of the lab, which is this, I started off with 4, just communities A, B, and C. So you can see at the top of each of those little tables it says community A, community B. 1, 2, 3, 4, 5. We'll actually have 5 bags out at any one time. So if you are doing community E, you can just scratch that all out, put in community E. Next year I'll leave them blank. Now I know. It's the first year I've done this. So you're probably only going to get through 2 communities. You're going to calculate an index of biological diversity, the Simpson's index, on each of them. And then we're going to rank them. And we're going to talk a little bit about what those numbers mean and what those relative biodiversity levels mean. So I'll hand you your beans and get you started. So if I was doing the pile that I've got up here, so I'm going to take my sample and I'm going to write on the grid, Great Northern, Lima, Pinto, black-eyed peas, BEP, however you want to abbreviate it. And then I'm going to count. So for Lima, I've got 1, 2, 3, 4, 5. For Great Northerns, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm doing a terrible job here, but that's okay. For Pintos, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Black beans, 1, 2, 3, 4. Let's just pretend I counted that. And for black-eyed peas, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then the next column for me is going to be n times n minus 1. So this would be 9 times 8, or 72, 56. Why do I always get those mixed up? 72. Thanks. This will be 5 times 4, 20. This will be 10 times 9, 90. 14 times 13, well, it's more than 144, I know that. And this will be 10 times 9, which will also be 90. Then here, you're going to add those up. So you're going to just add up the numbers you have here. Your calculation, where you show calculation, that's going to be D equals sum of n times n minus 1. So that's the number in that box, over, I have to add these, so 20, 34, 39, plus 9, 48, over 48 times 47, okay? No, you just take a sample. Because remember, when you're sampling a biological community, can you count every individual? No. You can take a sample. Should your index of, and this was just an example, do not copy my numbers. Your samples in a biological community should be representative of the whole community. So you get going and I'll walk around and help if you need me. I should have been recording this whole time. Oops. So we've got a variety of scores, but we can generalize and say that D is clearly the least biodiverse. If I was guessing, maybe D is like old strip mine land, old industrial wasteland, vacant city lots tend to end up looking like that. And you get 1 or 2 species that dominate the whole thing, and it's just not terribly diverse. C could be a patch of relatively old growth forest. That could be something out in the state park or in the state forest. That could be, we don't know what these ecosystems are. But if you're going to pick one to bulldoze, I sure wouldn't pick C. preserving biodiversity is fairly important for, well, and I'll give you the selfish and the unselfish reasons. So there are crazy people, and I'm probably one of them, who think that, other species kind of have their thing going, and maybe we ought to let at least some of them survive. We are changing the world. We are changing habitats radically. We've been doing it for a long time, and we're not the only species that does it. Beavers change habitats radically also, but not to the extent that we do. I've never seen a beaver paving anything, not once. If you find photographic evidence of this, please send it to me, because I would love to see that. Humans have changed habitats globally for a long time, and we're continuing to do so. In general, habitats that humans have changed dramatically end up being a lot less diverse. So, the not selfish reason is, well, hey, maybe we ought to leave some diversity out there. The selfish reason is this, and I give you this directly from a friend of mine. She's also a biologist. She went a different route with her biology than I did. She works for a pharmaceutical company. And she actually designs clinical trials for drugs. When they're trying to get a drug approved, she is the person who manages those drug trials and makes sure, so you guys did a little bit of scientific method with your research, she makes sure that everybody's adhering to the scientific method. Are all your controls in place? Are you controlling for this? Do you have all your permissions in place? That's her job. And she's got a couple little kids. She's a nice person. No farm girl by any stretch of the imagination. Not a big, nature person. But she has said, we were having a conversation, somebody said, who cares? Just bulldoze it. And she said, no. The cure for cancer may be in a rainforest plant that we've never seen yet. We don't know what's out there that's useful to humans. And that's true. That's the selfish reason to preserve biodiversity. Are there species of bacteria living in soil in a forest here that hold the secret to a new antibiotic that can't be resisted? That'd be nice. So we don't know what's out there. That working machine, the higher the level of biodiversity, so the lower the Simpsons index, the more moving parts there are in that machine. What was the t-shirt I used to see all the time? It's a bad mechanic who throws out the spare parts when they're done putting it back together. When you put it back together, you shouldn't have any spare parts, in case you didn't know that. We don't know what all the parts do. We don't know that any of them are spare. And that's one argument for preserving some level of biodiversity. So my original plan was that you were going to have a video that would post Sunday afternoon that would lead us into the thing we're going to do for 2 days before your test. I pretty much scratched that because you've got the relationships thing to finish. That is due Monday. I changed that. I think I told you guys that. You also have the questions on this due. You don't have to do additional bean counting. I'm not going to make you do that. But you've got the questions on this due. You've got the relationship thing due. Monday and Tuesday, we're going to spend 2 days talking about how communities respond to change, what that process is called, how we move through it, and which kind of communities tend to respond best. And then Wednesday, we're going to do some wrap-up review, tie it together. Thursday is your test, which means Part C's are due Thursday. Friday, you will not want to miss because it is Gamete Day. It is where we start genetics. And yes, I will literally have gametes here. It's so exciting.
What are those?
Well, you'll have to go look it up. It'll be on your vocabulary packet that you'll get Thursday. I imagine it might be the first word you look up. So anyway, it's a very exciting day. I love Gamete Day. It's lots of fun. So anyway, that's it. All the beans are back. You've got your numbers. You're answering questions. Go for it. Have a good weekend.